Good afternoon, everyone. You know who I am, so I'm not going to tell you who I am. I want to introduce to a very special person. Yes, it's him. I want to introduce you to Peake Lomas, who's one of the core inventors of the Raspberry Pi. Over to
I spent 5 years lecturing, so I hope everybody can hear me. I have a reasonably good projected voice, and it's not as though we're in a massive auditorium, so I just feel more comfortable without trying to hold a mic and this, and I get confused. So, yeah, I just sort of want to take you on my journey of computing and dip in and out of Raspberry Pi and a few other things along the way. Hopefully it'll be interesting. If you don't find it interesting, the door's over there. I'm quite happy. I always say this, and nobody ever does. Well, actually one person did, but then they came back. Oh, is it raining outside? You have to think about that one. Anyway, so I just want to sort of take you through also where Raspberry Pi started, why it started. Well, I think just to start, this is a thing that Bill Lowell, one of the founders of Coder Dojo, talked about, and I'm just going to nick it because it's a great idea. And it's to do with the fact that, I think it was Arthur C. Clarke that said any sort of advanced technology is indistinguishable from magic. And I think he was right, because if you take some code and you take some electronics, if it will move, you end up with things like this.
There you go.
Hey! So this was a almost line-following robot. But what we wanted to do was give the kids the ability to get involved with things like this, to actually understand how it works. And so that was sort of an inclination. But what I want to do is just sort of wind back to where I started. So I'm a Salford lad, so not too far from here. I wasn't exactly brilliant at school, I think it's fair to say. My best O level was technical drawing, that might give you a hint. And I think the reason why is because I feel that I'm a creator and a maker. That's what intrinsically I am. And so when I was young, there wasn't a great sort of, we weren't exactly the richest family on the block, and presents were basically reconditioned versions of my brother's presents, like, I'm sure my brother had a blue one of those last year. This one's red. Yeah, but you get the picture. But you'll notice in that we had a corner shop, and corner shops are brilliant because they have this stuff. And cardboard is a great creative material. Now, at school, I maybe wasn't good at the academic side, but I was very good at these marble games that we used to play in the schoolyard where, if you hit one of my marbles, you get two back and all this sort of thing. And ended up with about 7,000 marbles in the space of about a couple of months. And carting them in and out of school was a bit of a... But, of course, you can then do things like this. And I'm hoping that this one's going to run as well, but we do seem to be having a problem. But let's see. Success. And yes, you can hear the errant one that went under. And the thing about this is, right, you don't realise it, but you start to learn the law of physics. You start to learn about momentum. Because if you don't, they all end up under the sideboard and you've got to retrieve them. So you talk about the angle, the potential and kinetic energy. But they didn't teach me that at school. If I asked why, it was like, shut up, just learn it, right? And that really didn't work for me. I mean, you could have dreams about other things that you might want to make. They didn't quite work out as you planned, right? But it was still great fun. Had 4 wheels, what's wrong with that? Yes, you needed sloping land in order to make it do something. And I used to get in terrible trouble because I'd come back with my school shoes slightly scuffed off on the bottom because I was using them as brakes. But hey, I think the big change came when I was 13 and I was allowed to go into Manchester. Now, many of you might remember that Manchester had a place called Tib Street, which was like the mecca of bits of electronics and bits of old. If you wanted a valve, then there was a valve shop there. You could pretty much get anything. So I went. Now a few weeks, and then 1 week I came back with a quarter of a telephone exchange. Now getting that on the number 8 bus was a bit of a struggle because it was nearly as big as me, but you know, it was fine. And it's made up of bits like this. Some of you might recognise them.
Yeah.
Some of you absolutely won't, right? Don't worry about it. So what I did is I took all those bits of that telephone exchange apart, so I took everything, cleaned it, and I rebuilt it into a noughts and crosses machine. And I had a little telephone dial for putting in the noughts and crosses, you know, so I could put my moves in, then the computer would then make its move. Now, of course, this is a stored program computer, but I didn't know it was. It was just a thing because it was easier to make something to play noughts and crosses with me than it was to get my brother to play with me because he just couldn't be bothered. So that was my first introduction to sort of, I won't call it electronics, electromechanics I think is the right thing. And also I found out that when the family found out that the reason the TV kept having zigzag lines all over it, it's because the amount of EMC that came off this was absolutely horrendous. But you know. So I would say I wasn't the greatest at school, so I started off with I think it was a 1 in technical drawing, I can't quite remember now. And then maths was down here somewhere, and then physics was down here somewhere, and then chemistry was down here, and then sort of English and French were sort of down here, right? And the French was actually spectacular. I think the word was your Viva was the worst in the school because you didn't actually use any French at all. But hey, you know, that's it. But all is not lost. So I left school at 16 and I went to a technical college. And the great thing about this technical college was, one, it was in Bolton, so it wasn't too far away. But the other is they had stuff. They had stuff you could play with. They had things that you could actually modify. You could play. So I'd done in physics, I'd done Pelton wheels and didn't understand a word of it. But when I physically saw one and actually started playing with it, all those equations that, you know, they were trying to make me learn just all sort of made sense. Now the other thing about that is they also had at the college one of these. Now, for those of you who don't know, most of you will, that's a PDP-8. It was the first, I would say, reasonably sized desktop computer that you could buy, or a college could buy. I mean, they were about £30,000, so I mean, you weren't going to get one for home. And I walked into the room where it was, and it wasn't a room, you know, probably a little bit smaller than this, and there was a guy there, because of £30,000 they were going to look after it, so they had a technician whose job it was to supervise it. And I said, oh, that's nice. And he goes, yeah, well, what course are you on? I said, ONC Electronics. He said, oh, well, you're not going to be able to use it, this is for the degree students only. So as I turned on my heels, pretty peed off because it looked quite interesting, he said, well, you could always come back at lunchtime. I thought, yeah, I suppose I could. And of course I did. And then he sits me down at a terminal, right? And, well, let me just show you a little video if it plays. I hope this is going to play. Because that's the real thing. This is how you interacted with a computer in the days when I first started. And of course it was the inevitable program of 10 Hello World. So he teaches me how to do this program. And he just stands there. And just stands there. And I'm thinking, oh my God, how do I make this stop? And I think there was a bit of a smirk on his face. He was waiting for a bead of sweat to appear on my forehead. And then he leant over and typed that mystical Control-C and everything goes quiet. Yeah. But that was hugely life-changing for me, because actually he spent the time with this Scotty kid from Salford. He encouraged me that I could actually do it. He gave me some sort of impetus to get in there, and he would help me if ever I got stuck, because computing's a journey. It's a journey for everybody. We're learning every day something new, something else that's broken that we need to fix. And so if I got to one of these really steep bits, he'd give me a hand. So of course, I went back 300 and something lunchtimes. Basically, I was a lot slimmer than I am now because I never ate at lunchtime. I went straight back, played on the computer. Got into terrible trouble because I figured, right, I'm basically lazy. I figured that if I could work out what the code needs to write, then I could get the computer to do whatever I needed, like lab experiments. So there was a famous pentode experiment that it was sort of hot and sweaty, and it was always the summer when you had to do it, close to summer. Oh, I'm not doing that. So I went to the library, looked up all the formulas, typed all the formulas into the computer, plotted all the graphs, and submitted it, and then got hauled in front of the prof. Because what I didn't know is that their pentode experiment had a little bit of a glitch on it because it was slightly faulty, and there was always a notch in the results, which my results didn't have. So clearly I'd falsified these results. So then I had to fess up what I'd done. But I also argued the case that because I'd basically written a simulation of a pentode, I knew more about how they work than anybody else, and just about scraped away with it. Just about got away with not getting kicked off the course. But then, of course, what I wanted to do is get into the best place to learn more about this fantastic technology. So I then looked around, and of course the place to go was Manchester University, where the first stored program computer was created, and one of the masters of computer science actually was still lecturing. Now, that was a bit of a problem because I was an OMC electronics, so what I did was I had to apply for electronics at Manchester, and I applied, and they said, yeah, where's your English language and your English literature, which you need for matriculation? Yeah, I'm working on that. I mean, and I had to do it. I just had to find a way of passing those exams. But then when I got to Manchester, I used a very little known regulation that if you don't like the course you're on, then you can apply to change to a different course, and if they're prepared to accept you, then you can change. So the professor of computer science was a bit quizzical. He said, now, let me get this right. You're on electrical, you haven't been to a single lecture, and it's still Freshers Week, and you want to change to computer science. And I went, yes. But I was in front of him, and that was my 10 minutes to convince him that I wanted to do computer science. Well, I only needed to describe what I'd been doing back at Bolton, and he went, yeah, okay. And that got me into computer science. So as you can see, my life is starting to build up to be a lot of twists and turns. A bit like this building, really. But that's fine. So I did that. I managed to get in there, did a first degree, did a second degree, taught for a number of years. But then, the thing I was really missing was my making stuff. So today, and in fact, since I essentially left university, I've been on the dark side, on the industrial side of making bits. So I have a company called Norcott, which is out in Widnes, and we make electronic platforms for people to put smart software on. I don't profess to be a software engineer. I mean, I've done a load of basic and databases and Pascal, and when needs must. But my real passion is in the hardware, making bits of smart hardware. And I'm quite lucky that we get to make bits of hardware for things like this, the Large Hadron Collider. Now, I also know that, I think in the opening, Professor Steve Ferber came down here to the museum. And so we built this, the electronics for, sorry, oh, I've missed it out. Slides disappeared, I've got two the same. We built Steve Ferber's neuromorphic computer, which had 1 million computing cores. Absolutely huge, and I apologise that the slide is, for some reason, duplicated. But anyway, so I spent my life building bits of electronics, and that's important later. But what Graham did for me, right, and his name's just etched in my head, I mean, that'll never disappear for what he did. I would have probably been an electrician on a building site if he hadn't given me that opportunity, so it's hugely important. I was always looking for a way of, if you like, I never knew it was playing it forward or paying it forward. I think it's called paying it forward, right? I wanted other people to have the same opportunities that I had. That was my goal. That was my nirvana. If other people could have the opportunity to do that, then I'd be happy. But I went down to it was like a seminar at Imperial College, because we built some electronics for impossibly complicated electronics for Imperial College. We've got it working now. Do you want to come down and see it? I thought, London. And we know how all of us are enthusiastic about going to London. Well, I thought, yeah, okay, I'll go. So I went. And at lunchtime, we were walking over Hyde Park. And I just got chatting to this guy. I had no idea who he was. But it turned out he was Alan Mycroft. He was Professor of Computer Science at Oxford, at Cambridge. Oh, sorry, bit of a slip there. At Cambridge. And while we were walking across Hyde Park, we got talking about the problem they were seeing, the student numbers decline. They were also seeing the fact that students were coming to the university that had never created a program of their own and debugged that program of their own. It had all been what we call the rote version. Take this piece of code that you've got, modify it in this way, and do this, do that, do the other. There was no creativity and innovation in what we were doing. And we surmised that there was a real problem here. And one of the problems is you take this bunch of scouts, they're not being creators, they're being consumers. And the reason that they're being consumers is because they're faced with all of this. All the computers you could take apart and you could add things to, of which there is a vast array upstairs, had all disappeared. They'd all been annihilated by the fact that the PC arrived, and the commercial side of what you could do with those computers had disappeared. I remember people running their businesses on Spectrums. Yeah? You could just about do it with a piece of code if you didn't switch it off and have to reload it back up tape. And it was doable. So we saw that there was an opportunity to create a little computer. And of course, so I had a room in there. We had some academics. We had Dave Braden from Frontier, Jack Lang, who was sort of like an entrepreneur, and Evan Upton, who was a silicon chip designer. Maybe we need somebody to make this stuff. And you just go looking around, then you realise, of course, that's what I do for a living. So I was the obvious choice to do it, so I volunteered. We were only going to make 3,000 ever. This project was only ever going to make, so I said, 3,000, that's not much. We're going to make them over 3 years. It's fine, you just send me the chip, I'll just make them. When I'm quiet on our production lines, I'll just push the load through. Yeah, I didn't realise how wrong we were there. But then we said, well, let's expand this, not just to the students coming to Cambridge, give it to them and then see what they, basically, you give them the computer, be about 6 months before they come to Cambridge, they come for their interview, bring it, they show you what they've done. If you haven't done anything, probably just send the computer back, it's probably not worth coming. But we wanted to expand it because we could see potential to recapture some of the things we had with all the say, small computers. So we created this thing called the Raspberry Pi Charitable Foundation. Now, I agonised a lot about this. Which idiot would call a computer a Raspberry Pi? And that's basically where I started. It was only after a few months I realised it was a stroke of genius, because it made people inquisitive. It also made kids inquisitive. So that was great. And that was fine, and we started looking at designs of what we could do. And it was all sort of starting to come together there, but we were missing something. The thing we were trying to do initially was to create a Python-based BBC. So instead of booting to BASIC, it would boot into Python. And we had a sort of a way that we thought we were going to do that. And that's where the Pi part of it comes. It started with PY, but that just looked naff, and PI just works a lot better. If you go to Brazil, right, they insist on calling it Raspberry Pi, right? I can't imagine, they've obviously been watching too much Magnum PI. But anyway, so everything was going slowly until this happened. And that's Dave Braben and Rory Kessman-Jones, who's now retired, and if you follow him on Twitter, he's more of a dog addict now than a computer addict. But he just did a little presentation and put a little YouTube video on. Now that in itself isn't surprising, but then we got 600,000 hits on that little video. Now back then, it was a lot. You know, now that's really in the detail, isn't it? I mean, you know, I think only one of the Kardashians has to cough and that'll get 600,000 hits. But you know, it was a different place then. But what it meant is that we really needed to up a gear and we needed to get on with it. So we created a website. And of course, the first thing we put on the website was what we were going to make and how much it was going to cost. Now, I have to admit I had no involvement in this pricing policy. I was told that this was the price of a textbook, right? It was important that it was going to be cheap, because it had to be cheap enough to risk breaking. Because if you were scared about breaking it, you wouldn't invest in doing things with it for the fear. I mean, nobody is going to let somebody take the back off their MacBook and start putting wires on so they can connect an LED to it. And so that was an important thing about the mission. So I said, they told me it was going to be the price of a textbook. I've been into Waterstone's, price of a textbook was between 70 and 80 quid. I thought, yeah, fine, no problem. Then this happens, right? Oh my God. But then we just had to start being creative. And the thing that was most important is Evan, being a chip designer, came back with a chip, the BCM 2835, and it had an ARM core on it. And this was a massive change. This was, if you like, the defining moment. Because at that point we realized we could, with a bit of fiddling, we could run a version of Linux. If we could run a version of Linux, we could embrace all that community software that already existed, and that massively upped the value of what this had been. I sort of break out in cold sweats now thinking if we'd actually gone down the original line and it had been a little Python computer that you'd probably have to load in from audio tape, would we have actually done it? Would we have actually succeeded? Nah, I don't think we would. Anyway, it was a frantic sort of 4 months where basically I'd finish my day job about 5:30, have a sandwich, and then sit down at the computer and do Raspberry Pis. And it was getting towards the end of November. I could tell Evan was getting impatient because he'd phone me every night. He knew where I was, so my desk phone would ring, usually about 7 o'clock every night. He goes, how's it going? I said, fine, I'm just trying to do this or just trying to get that done. It was funny though, he phoned me from Heathrow Airport. He was flying to the States for a meeting for his company. And he was in the lounge and he said, look, I've got an 8-hour flight, send me the bomb. I'll work on it while I'm on the plane. And he said, from about that second, he noticed everybody starting to move away from him. And these rather burly gentlemen starting to congregate. He then realised that he needed to translate that to bill of materials, and perhaps they wouldn't be quite so interested. That could have been a hairy moment. But anyway, towards the end of December, we had some free time on the production line and we built the first prototypes. And I got them to the lab. It was about a week before Christmas.
What year?
Was 2011. I plugged them in, absolutely nothing happened. So I got a second one, plugged it in, absolutely nothing happened. Got a third one thinking, absolutely nothing happened. And you know how, this is the point where electronics rearranges your anatomy because your heart moves from up here to somewhere down by your foot. You think, what have I done? Right, what have I missed? It turned out that the data sheet was a bit crummy and there was an input and output. This is my excuse and I'm sticking to it. It wasn't clear whether this was an power input or a power output. And in fact it was a power input and I thought it was an output. But I do think that there is some entity somewhere that looks after you because this is a BGA, right? Trying to wire to the underside of the BGA is impossible. So we just thought, oh God. So I scrutinised the schematics, scrutinised the layout, and then a miracle happened. Because we had this, the Raspberry Pi Classic, okay? Didn't work, but all we had to do to make it work was, you see where that scalpel blade is? There is literally a pad in the middle of a land of copper. We needed to connect that pad to that land of copper and everything would be good in the world. So basically we just had to scrape off a little bit of this green stuff, which is a solder mask, blob the two together, they worked. And this was then 2 days before Christmas. So Eben and Liz came up, I gave them all to them and they went round and went to all the programmers, Merry Christmas, here's a Raspberry Pi, can we have Linux on it by New Year please? So they didn't thank me for that. But then we had a prototype, we knew it worked. We were pretty certain that Linux had run on it. So Liz thought it'd be a good idea to ask people who might be interested in buying one of these, because we sort of broadened our aspect, so it seemed fair to ask people if they might want to buy one. So we had a little bit of a side bet. We thought we might get rid of 1,000 if we were lucky, maybe a couple of thousand. And then this happened. We had a $10,000 order because we thought that would do us for the next 3 or 4 years, and 200,000 people said they wanted a Raspberry Pi. Now, just translate that into financial numbers. That meant that we needed to find $5 million to build those. Otherwise, we build 10,000, sell them, build another 10,000, sell them. But at that point, people are going to get peed off because they're not going to get them quickly enough. I mean, you'll have had things where projects have got too big and too successful and implode. What are we going to do? Well, fortunately, quite a few people in the Raspberry Pi trusteeship had all been to business schools. And they said, what we need to do is we can't build it, let's license it. So we licensed it to Farnell, RS, and Allied, which is an RS version in the States. And they basically took on the heavy lifting of spending the money and getting it built. Initially they were built in China, but we very rapidly brought them back and got them built at Sony and Pencoed in Wales, and they've been built there ever since. On launch day, which Eben amusingly decided would be the end of February on the leap year, we sort of primed the world that it would be 6 o'clock in the morning, be there, be ready, and this happened. Within, I think it was 4 minutes of 6:04, the Farnell website went down. It looked like a denial of service attack. It was. It's all these people trying to refresh the screen, trying to buy a Raspberry Pi. RS went down, then our website went down with all the people trying to ask why they couldn't buy a Raspberry Pi. At 8 o'clock, I had a deputation from my purchasing department going, "What the hell have you done? I can't buy any components today because all the websites are down." Well, you know, they told us they were ready, they just didn't know how ready they needed to be. Within about, it was about 9:30, they'd put up a temporary redirection, and then we were all back, everything was back in business. But obviously, it became huge. And by huge, we've now surpassed 50 million Raspberry Pis out in the wild. Maybe that's something, you know, we should sort of look at. So one of the first adventures that Raspberry Pi got was by this guy called Dave Ackerman. And basically he put a camera on the Pi, he put the Pi in a box, he put a GPS in there, he put a battery in there and stuck it on the bottom of a weather balloon and sent it up into space. That was quite a hairy moment because I thought, is it really going to survive that? Because it gets pretty cold up there. Turns out that cold wasn't the problem, and the depressurization wasn't the problem. It's the fact that the GPS broke and they couldn't find it. But he got quite sophisticated. He had this control room for tracking them after a while. And he kept doing it and doing it and doing it. And it's great because it engages kids in computing and also other things like physics and space. And I'll come on to that in a bit. This is one of his less successful attempts of launch. I know it's hard to see, and I don't know if this is going to work, but basically, you see, this is the problem with these. Nobody gives you a laser pointer that works on the TV. So I shall use the other alternative pointer that I made earlier. That's where it exploded, and it comes down in the sea and washed up in, I think it was Denmark, a few months later. We got it back, and the SD card still worked. We got the pictures of it. Tremendous. But I was talking to some scouts at a scout meeting, and they said, well, what happens? I said, well, the balloon just gets bigger as the atmosphere gets thinner and thinner, bigger and bigger, and eventually it bursts. And they went, no, it doesn't. I said, right, you lot, go off your tea break or your juice break or whatever. I phoned Dave up. Within 2 minutes, he sent me a picture. That's what happens to a balloon at the point of explosion. That, if you can see that sort of circle here, that is a real artifact. That is the, like, talcum powder on the inside of the balloon that allows you to blow them up so they don't stick together when you're blowing it up. So that was literally, that photo was taken literally nanoseconds after that balloon had actually exploded. It's a fabulous picture. And of course, they couldn't deny then that this is what happens. The other thing is you get fantastic pictures of near space. This got me into a lot of trouble actually because my then 12-year-old goes to me, I know the sky is blue and it's clearly black up there. What's going on? And I went, well, and I was thinking, right, I just need to go to the loo. Google, why exactly is the sky blue? And of course, we all know, and I knew then, it's Rayleigh scattering in the atmosphere that causes it. But of course, getting to near space is not quite the same as getting into space. So we managed, and I don't exactly know how, to get involved with this guy. I must admit, he looks a lot younger in this photograph because I realised it's quite a few years ago. And we teamed up with all these people a collaboration with the idea of getting Raspberry Pis in space. And what we're going to take into space is this, which is a standard Raspberry Pi with a thing called a sense hat with lots of sensors on it and a display and controls. It turns out it's not quite as easy to get that into space as you'd like, because the first thing I learned is all the thermodynamics you've done all go a bit out the window, because a lot of stuff on Earth is convection cooled. That didn't seem... But when you don't know which way is up, warm air has a habit of not going anywhere, as is demonstrated by this. So you've got a flame on Earth and a flame on the ISS. How they do that on the ISS, I didn't quite go into the detail. It just seemed a little bit risky to me, but basically it just stays where it is and it doesn't burn anything like as well. So sadly we needed to put it in a flight case. So there's quite a lot of engineering in making that flight case to distribute even the small amount of heat that a Raspberry Pi then actually generated. It then has to go through, and I'm going to skip through these quite quick, it has to go through a number of tests. The first one is that it fits on one of these things called a bogan arm. Why? Well, because everything on the ISS is connected. Because if you don't, you turn around and it's drifted off. So they have these arms everywhere that you can connect stuff and stop it moving off. It also has to pass EMC testing, so you have to put it in the chamber and make sure it's not going to damage any other equipment by radiating things it shouldn't. It has to be vibrated within an inch of its life to make sure it's actually going to survive when it's launched. This is an interesting one. Because it will be in a depressurized environment for part of its life, you have to make sure it doesn't outgas any nasty chemicals that may actually affect the astronauts. The list goes on. I mean, the list is huge, and the book that Dave actually had to fill in to do it, and I think he's on here somewhere, is huge. Then we have to do surface temperature tests so we don't burn the astronauts. I mean, the list is endless of things you're not allowed to do to astronauts. Right? This is the funky one. This guy wears really delicate gloves, and he basically just feels the unit all over. If he snags a single thread, you failed. So it gets through all of this stuff. And then it also then has to go into the Columbus simulator. You've got to write all the manuals for operation manuals for it, all this sort of stuff. But it was absolutely worth doing because we created this thing called the Astro Pi competition, which allows kids to write code to go in space. I mean, as Tim said, your code in space, how cool is that? And it is, and it's running today, and it's absolutely fabulous. And one of the early winners was Hannah Belshaw, and she actually did a thing with Minecraft. She took the data and then orientated this simulation of a Minecraft ship of the ISS in Minecraft and orientated it as it was from the data, which was brilliant. And you could get Steve to fly around it and look at it. It was a brilliant idea to use Minecraft in that way, and a lot of kids use Minecraft in very creative ways, which is fantastic. She then managed to get on the One Show. I thought this was really unfair, actually, because they made her wear this spacesuit. Can you just imagine how hot that would have been with all those lights? It's just horrendous. Anyway, my favourite is these guys, Cranmere Code Club. They did one, and what they did is they used the moisture sensor to sense the presence of an astronaut, right? Because if an astronaut was close, then the humidity would go up fractionally in around, and then they take a picture of them and they say hi on the display. That wasn't the best bit, is they had to put their code on GitHub so we could review it, and this is what they called it. Which I thought was fantastic. So we had to get them to the ISS. How does that work? Well, quite simply, you stick them in a cargo ship. They're basically the FedEx of the space exploration business. And we were in there between, what was it? A CWSA, and I'm never quite sure what that was, and a pack of trash bags. But, you know, as long as we're there, I don't care. Now, the launch came, and you can see the weather was atrocious. You can see how windy it was by the white tops on the water. Dave, who'd done all the work, we shipped him out there so to watch the launch.
3, 2,
This was the third day, and it was actually going to go.
lift off. On the shoulders of Atlas, the SS Deke Slayton II orbital ATK Cygnus spacecraft soars toward the International Space Station.
Which was great. But they had a water leak at the Space Centre, and the sort of way the rules work, we have a water leak, the toilets don't work, so all visitors have to leave. So Dave had to leave. He ran round to what was called the Banana River, and this is what he saw. This is all he got to see. Just he's not sure, that's it. Then he disappeared in the clouds. I just felt so sorry for him for all that hard work. Anyway, that's the cargo ship being picked up by the Canada arm and actually getting loaded onto the ISS. But of course we needed Tim. Now Tim was coming up in a separate vehicle out of Russia, Kazakhstan. Don't think we'll be doing that just at the moment. And then he was there up on the space station in the Columbus module with the Raspberry Pis. And this is a picture that we got, I think it was just after Christmas. This orange, this sort of pinky glow is from a project for growing food on the ISS. And they're trialing all that stuff because for deep space they're going to want to grow food. And the other thing that got me was this picture, which it's not easy to see, but this is Izzy. This was the one with the infrared camera fitted. And that photo is okay, but when you see the bigger photo, behind that door is space. And it's just quite hard to sort of get your head around it. But, as I say, the plan was to get code in space. And that worked really well. ESA have taken it on board. AstroPi lives on. There's actually now 2 new AstroPis on the International Space Station. Izzy, if I'm right, you can see in the Science Museum in London. And it just is a fantastic project. So there you go, cardboard to space, but of course Tim had to get back. And this is Tim's capsule landing. If you look very closely, you'll just see the retros firing just to soften the blow as they hit the ground. They actually make a sort of foam encasement for the astronauts that's absolutely perfect to their body. So there's no bit of their body that's not supported. But as Tim said, that was great, but that was made on my way up. When I came down, I was a bit of a different shape. And so quite a few bits hurt when you hit the ground. But that's what it's all about. But the mission, right, is about putting this digital making in front of the kids, giving them an opportunity. And all the stuff that you've got here at the museum actually helps that journey because it's some of the old stuff that we played with, but it gets them interested and getting interested through games. We want to take them off the screen, so we start using LEDs. So the starting point is there's an LED, make it light. There's an LED, make it flash. There's another 2 LEDs. Oh look, we'll give you a yellow one and a green one. What could that be? You've got a set of traffic lights. Now code them so that it makes it into a set of traffic lights. Here's another set. Make them so that the other side of the traffic lights. Here's a button. Now you can have a pedestrian crossing on it. You can expand infinitely. But if the kids want to go in a different direction, they can. And then they can start bolting things on and making robots. And robots, I think, has probably been our biggest seller in terms of where the actual passion for a project comes in, is making robots. And a great part of the community have created Pi Wars. Now, it's different, right? Because in the Robot Wars, they smash each other to smithereens. In Pi Wars, it's about a set of tasks you have to do. and that's really, you know, it's really powerful for improving coding skills, but it needs mentors to actually help the kids along to get it done. So the thing I always say close to the end of my talks is that giving kids opportunity, spending a bit of time with them, helping them on that journey, helping them across the bumps in the road for the thing that they want to do. Because the core is, if it's something they've thought of, it's something they've coded and built, and it's theirs. There'll be tears along the way, but when they get it working, the absolute power of that moment will solidify their ability to be makers forever. And I just want to finish with what I found was quite amusing, which was an ad agency. I think they were in Sweden, and you've got to spot the Raspberry Pi if it plays. And all done with one of these. And it's all about being innovative and being creative, especially for kids. But, you know, us older people can do it as well. And that's me. Thank you very much. You have to use that. I know. I think everybody can hear me, can they? Yeah, we can.
Well, I don't know about you, but I'm totally blown away. And you obviously, because we do Raspberry Pis in our educational suite, but this is just
Somewhere else, yeah.
Yes, yeah. It's about there, isn't it? So, yeah, I'm just absolutely amazed. So, but thank you for coming. We have got another couple of talks, so we've got.
How long have we got for the next one?
Probably about half an hour.
So if anybody wants to ask any questions, I'm going to be here for another couple of hours yet. You can either ask me now or buttonhole me when I'm walking around. If anybody wants any stickers, I've just accidentally purloined a lot of Raspberry Pi stickers. Any Raspberry Pis? No. Do you want to chat? Well, you can have a chat with. Do you want to ask a question or you want to chat later? I'm not sure.
Can I ask a quick question?
Sure.
You know, when it was going up to the International Space Station, he said there was a number of tests. Was there any tests where they said, oh, it's failed on this, you're going to have to go back and fix this? So, like, he said, like, you had to do the gas test or the heat
No,
test?
they helped us tremendously and said, they reviewed everything before it went to test and went, you might just need to do this to make that work. You might just need to do this. We had to conformally coat the boards because the worry you have in the International Space Station is what happens is a bit of metal off your board comes off and starts drifting around in the space station, gets into some other part of the space station, shorts something out, causes that to implode. You're not going to be the most popular person.
I guess.
So it's all about that. And then you see the astronauts, because I have a sort of regular feed. You see the astronauts there. They're there and they're messing with water. You know, they're making blobs of water and leaving it in space and then trying to eat it or drink it. I'm not quite sure how it works really in space. And so they do all that sort of messing around. And it's a great thing for getting people engaged. It was quite funny. A few weeks ago, of course, there was this big thing about the Aurora Borealis, wasn't there? I really ought to try and find it. If you've got a minute, I will actually look for it. And I was talking to Tim about it. He said, rubbish. He said, you haven't seen the Aurora Borealis until you've seen it from space. It's absolutely fantastic. And I will try and, if people want to see it, I'll try and find that video. I might have it on my laptop. But yeah, no, we got through. ESA were hugely supportive because they knew that we needed some vehicle to engage kids in the space program because it's going to be the next big thing. Okay,
Thank you.
If it doesn't get overtaken by AI.
No.
But AI is not going to get us to Mars, right? So, and we will ultimately have to go, I think.
your favourite schools project that you've come across using the Pi?
Ah, right, okay. This is terrible, right? My absolute fave was we were doing a project. I went and did a school project, and it was in Blackpool. And the basic plan was, we're actually using a sense hat, okay? And the thing was, you have to make a flag pattern on the sense hat. The winners would get their pattern put on Blackpool Tower for a week or so as part of the illuminations. It was a fantastic sort of engagement. And there was this group, there was a boy and 3 girls, and they were sat at this table and they were trying to do it. And they were just absolutely struggling. And they weren't happy, and we had a few tears, and we had loads of stuff going on. And then I need a prop. Actually, I was wearing this at the time. So I was talking to somebody, and we were just having a chat, and I was just there minding my own business, and I could feel this on the back of me. And it was the girls from that table. Come and see this, come and see this. And I won't say it was the best flag, but it worked, and it was theirs. And the joy in their faces, and they were so high-fiving it between the 4 of them. It was just brilliant. So it wasn't the most complex. And that, I thought, was absolutely brilliant. On the technical side, it has to be a couple of students from Duisburg in Germany who actually hacked, they took a Raspberry Pi, they hacked a camera to make it an eye tracker, and they actually bolted that with some Arduinos and some control onto a wheelchair and actually made an eye-controlled wheelchair. And these are students that were what? I think they were 15 and 16. And I've met loads over the time. Celine Ornick from, where I met her in Coolest Projects in Dublin, and she's making robots. And this is quite a while ago now, this is what, 6, 7 years ago. She's now just been awarded a scholarship to Stanford to do robotics, all because of what she did with Raspberry Pi and her interest in that, and that's fantastic. So although I can't really, every single interaction with the kids is special in some way. You know this film Monsters Inc., where they go and get the kids to scream and they steal the energy from the screens. I'm like that, but I steal the energy from their success of getting a project working. If I'm feeling a bit down, I just say, guys, where's our next activity with the kids, and can I go? And just the buzz in the room is just fantastic, because they're just so mesmerised by the fact that it's the thing that they want to do. They're actually doing it, and they're achieving something that's theirs. It's not what teachers told them to do, it's what they wanted to do, and that's hugely important. And it also has a very interesting educational effect, is that the education system pushes knowledge of kids. That's what it does, it just pushes. Why do I need to know? Just shut up, take this. Do the maths, make that work. Make that, do that. Don't fail and get a good result at the end. That's the system, because it's a mass process. That means that kids that are very bright, or the kids that are not so bright, fall outside that band and usually end up in trouble one way or another. I like to think that I was one of those kids, and I'll let you decide whether I was up there or down there, and I don't really care, right? It's the fact that the system didn't work for me because I was thinking about different things. I wanted that. I want people to explain to me why I needed to know this, because that was important. What I was going to say, what it does is it changes. Instead of it being pushed, the pulling. They want to know, how do I do this? What formula do I need to do this? If I need to calculate the speed for that from there to there, how do I do it? How do I recognise a green blob on the screen? how. And it's a complete change. And if you think about it, once you've got anybody in that mindset, they're self-developing. They develop themselves. They don't need anybody else. As long as the knowledge can be provided, the only problem they're going to have is when they get to a really steep bit and they need some input because it's in the just too difficult bracket to do alone. And that's the power of what Raspberry Pi, Code Club, Coder Dojo, and all the outreach activities tries to provide an alternative strategy to learning. Don't know if that answers your question. Probably took a bit longer than I should have done.
What's the best thing you personally have ever done with a Pi? You got running in the heresy factory, and no help from anybody else?
No, this is embarrassing. This is embarrassing. I've still got it, it's still on my workbench, so I'm trying. I built my house. I mean, you know, being a maker, I thought. So I bought a house. I took the plaster off the wall in the kitchen, and a chunk of the wall fell in because they'd actually bricked up a doorway, but hadn't bonded it into the rest of the brickwork. They just thought, oh, cement will hold it, but it will for a while. So it just went, boom. I thought, right, I'm not sure I want to live in this house anymore, so I flattened it and built a new one. And of course I built it all with the ability to control all the electrics through a Raspberry Pi. And the place where that unit has got to sit is still there, looking vacant. In my lab at work is the unit that needs to go there. The bit of code I need to make that work is half finished, and it's been about half finished for the last 10 years, because I spend my time doing talks like this and going out and about, and I never seem to have the time to spend doing my pet projects with Raspberry Pi. It's a disaster area, right? But I don't mind, because this is more important to me. This is massively more important than being able to do my own projects. And also, I'm not a very good programmer.
So you've not done anything?
No, nothing. No, it's not true. That robot that you saw, that robot that looked to it's completely drunk, that's mine. I was quite pleased with it. I had a set of sensors like this. If you're an engineer, I used multiple sensors, and by the speed at which the black line disappeared and the direction I could then tune the actual rotation to find it. So I used to say that, you know, that was perfectly damped rather than, and it beat everybody else. It was a competition. I did that as an outreach it was actually a US company wanted to do some outreach work. They set like a set of things you had to do, like you had to drive your robot up to a wall, and the person who stopped closest without touching it got the points. That was the line following, the quickest one round the loop, and they had maze, looking through a maze and all that sort of stuff, just to try and get people engaged in programming. But then they said, oh, well, come Pete, are you going to have a go? And I said, no, you've got to have a go at something. So I chose that one. So that was several midnight oils trying to work out how to get the lolly sticks and the sensors in the right place to get it to work. But yeah, I've done nothing. Pretty much nothing. Any more for any more?
That's a pretty big nothing.
Yeah, well, yeah, it's a little nothing. But it's made a difference, and that's the important thing. All right, thanks folks. I think you're going to let you all go and get out of this rather warm room, which I suspect that the CO2 level is rising substantively.